All right, guys, so we've talked about our soluble versus insoluble pieces, but now let's try and understand why certain things are going to dissolve and certain things will not. Okay, so if we think about our solute and solvent, there's going to be some interactions between those two molecules. Okay, and depending on those interactions, that's going to actually tell us whether or not we have something that's going to be soluble or insoluble. Okay, so if we remember back earlier in the year, maybe like November, December-ish, we talked about nonpolar versus polar pieces, right? This was when we were talking about our compounds, we talked about the bonds, and we talked about those intermolecular forces, right? So the intermolecular forces are really going to help to decide whether or not our molecules are going to be soluble or insoluble. So if we have a nonpolar solute with a nonpolar solvent, it generally will dissolve and it will be soluble. Okay? If we have a nonpolar with a polar, this will generally not, right? This will be insoluble. Okay? Same idea if we have a polar solute with a nonpolar solvent, that's again going to be insoluble. Okay? And if we have a polar solute and a polar solvent, we'll generally have a soluble, there we go, reaction. Okay? So what we can remember here, and we've probably heard this before, is that like dissolves like. Okay? So if we have a nonpolar with a nonpolar, or a polar with a polar, it's going to dissolve, okay? But if we have a polar with a nonpolar, then it is not going to dissolve, okay? But let's think about our ionic solutes, right? Ionic are kind of fully charged, so there's really strong charges. If we're trying to mix it with a nonpolar solvent, this is going to be insoluble. If we're going to mix it with a polar solvent, then it can go either way. Okay, we kind of saw this in the lab, but that's what our table is going to help us to decide. Okay, so our polar solvent, we said, hey, in water, that's something that would be aqueous. We had lots of different ionic solutes. We were able to decide from that table whether or not something was soluble or insoluble. Okay, so that's our biggest factor. Factor number one, whether or not something will dissolve or not, like dissolves like. Okay, the second piece that we can think about is temperature. Okay, so temperature and pressure, when we think about our soluble compounds, they're not actually always going to be soluble. Okay, they're going to depend on the temperature and pressure at which they're at. Okay, so if we have a solid and we increase the temperature, so as temperature increases, as the temperature increases, the solubility is going to increase as well. Okay, so our way to kind of understand why this is occurring, right? We've got molecules that got into the solution, and once they're in solution, they're interacting with our water molecules, right? The solvent molecules. And as the temperature increases, right, we give more energy to those liquid molecules. They start moving around faster. So maybe they interact with a molecule over here, then they interact with a molecule over here, then they interact with a molecule over here, right? They're able to kind of bounce around and interact with more molecules, so the solubility of those molecules is going to increase, okay? But now what about for gases? If we think about gases, right, we're going to think again as the temperature increases, the solubility is actually going to decrease, okay? So the solubility decreases because, again, we're going to increase the temperature, we're going to give them some energy, but we're giving that energy to gas molecules as well. If we give energy to the gas molecules, they want to move around more. They don't want to get stuck just interacting with our water, okay? So our gases, right, we're going to increase the temperature, the solubility is actually going to decrease. So something that's going to help us remember this, we're going to have table G here later that we'll look at, and we'll look at those slopes, okay? All right, so then let's think about pressure as well, okay? Oh, we got an example with this. Gases, right? If we think about soda that's sitting outside in a warm day, right, it's going to lose that carbonation, okay? That's a gas, CO2, that's dissolved in the liquid. As it increases, it loses that gas, it goes flat, okay? So let's think about pressure as well. For solids and liquids that are solutes, there's actually no effect from the pressure, right? Solids and liquids, right, those molecules are already close together, so they're not going to be able to be affected by that pressure, okay? But gases are going to be affected by it. So gases dissolved in a liquid, as the pressure increases, the solubility increases. Okay, so think about that, right? If we have a soda can and we put it under pressure before we open it, right? We're going to put it under pressure, seal it. There's lots of gas dissolved in there, and then we crack that top, and it releases some bubbles, right? It releases some of those gas because they can no longer be dissolved in that liquid, right? As we open it, we decrease the pressure. We decrease the pressure, that's going to let some of those gas molecules be released, okay? So, if we go ahead, we've talked about this page, we're going to skip over and talk about this page next, okay? All right, we're going to pause for a second.